shift, and today's class we discuss about total internal reflection and conditions of total internal reflection. Okay, what is meant by total internal reflection? Total internal reflection means before going to start total TIR. So we can say that total internal reflection. So what is meant by total internal reflection? So last class I told discussion about the lateral shift and normal shift. There is a conditions of TIR. Before going to tell the definitions of TIR, we have to discuss about conditions of TIR. The first conditions of total internal reflection is the light ray must travel from denser medium to rarer medium. Okay, the first condition of total internal reflection is first one. The light ray must travel from denser medium to rarer medium. The second condition is second one. The angle of incidence is greater than critical angle. So first there is the conditions of total internal reflection. So TIR, or we can say that the total internal reflection. There are two conditions are there. The first condition, the light ray must travel from denser medium to rarer medium. The second condition is the angle of incidence is greater than critical angle. So what is meant by critical angle? I will tell you later. The first condition is the light ray must travel from denser medium to rarer medium. The second condition is the angle of incidence is greater than critical angle. So these are the two conditions of total internal reflection. So for first one, so what is my total internal reflection? According to graph, according to figure, I will tell. First, you have to draw denser medium and rarer medium. Okay, we are incidenting the light ray. Angle of incidence I, angle of refraction R. So first, in last class we have studied when a ray of light ray is moving from denser medium to rarer medium, it will bend away from the normal. In last class we studied in the laws of reflection. We have studied when a light ray moving from rarer medium to denser medium, it will bend towards the normal. In second case, when light ray is moving denser medium to rarer medium, it will bend away from the normal. See in this case, one figure. This is one figure. The light ray, we are incidenting light ray. The light ray is refraction will takes place. It will bend away from the normal. In second figure, okay. So we are increasing the angle of incidence. So we are increasing the angle of incidence. So angle of refraction also increases. We are increasing the angle of incidence. So first one, we are increasing the, see the difference between first figure and second figure. In first figure, angle of incidence is very small. In second figure, we are increasing the angle of incidence. So angle of refraction also increases. It will more bend away from the normal compared to first figure. It will bend away from the normal. in second figure, when the angle of incidence increases, angle of refraction also increases. It will bend more away from the normal. If we more increase the angle of incidence, okay, if we increase angle of incidence, the light ray will not refraction will take place. It will reflect. Means when a ray of light ray is moving from denser medium to rarer medium, according to statement, what we can say that when a light ray is moving from denser medium to rarer medium, when the angle of incidence I, is greater than critical angle, when the angle of incidence I is greater than critical angle, the the light ray return back to the same medium, means the light ray will not refract, it will reflect in the same medium. So we can see we can say that total internal reflection. So according to statement, what we can say that a light ray is moving from denser medium to rarer medium. A light ray is moving from denser medium to rarer medium when the angle of incidence is greater than critical angle. When the angle of incidence is greater than critical angle, when the angle of incidence is greater than critical angle, the light ray will reflect in the same medium. So this phenomena we can say that total internal reflection. So see once again, a light ray is moving from denser medium to rarer medium when the angle of incidence is greater than critical angle, then the light ray will not reflect, the light ray will not refract, the light ray will reflect in the same medium. So we can say that total internal reflection. Next one. So come to the point, what is by critical angle? Okay, third point. First point over, second point over. What is third point is critical angle. Critical angle is means same case. We are telling same statement. When a light ray is moving from denser medium to rarer medium, a light ray is moving from denser medium to rarer medium, the angle of incidence at which the angle of refraction is 90 degree. When the angle of refraction is 90 degree, so we can say that critical angle, the angle of incidence at which angle of refraction r is equal to 90 degree. So then we can say that critical angle. See the statement once again. A ray of light ray is moving denser medium to rarer medium. A light ray is moving from denser medium to rarer medium. The angle of incidence at which the angle of refraction is 90 degree. Angle of refraction is equal to 90 degree. So then we can say that critical angle. So what are the conditions of TIR? The light ray must travel from denser medium to rarer medium. Second case, the light ray, the angle of incidence is greater than critical angle. So critical angle means the angle of incidence at which angle of refraction r is equal to 90 degree. So we can say that critical angle. So next one, applications of TIR. So there are 4 applications are there: mirage, brilliance of diamond, total reflecting prism, and optical fibers. So first one, mirage. So mirage means in a hot summer days. So we are by taking the figure. So we are indicating this line is land. Okay. In hot summer day, the land will become more hot. In hot summer days, land will become more hot. The air present near the land. It will become hot air. Okay, the air away from the ground, it will become cold air. See the statement once again. In a hot summer days, the land will become more hot. The air present near the land, it will become more hot, and its density is less. Hot air is having less density. And next, the cold air present away from the ground, it is having more density or high density. High density means less density, and high density, I will write low density and high density. So low density indicates means it will behave as a rarer medium. High density it will behave as a denser medium. So means when the light rays coming from the sun, the light rays are coming from the sun. First they will reach the high density, means they will reach the denser medium. When the light ray is moving from denser medium to low density means rarer medium. When the light ray is coming from sun, reflection to denser medium to rarer medium from each level of air. So they will bend away from the normal. In this case, the total internal reflection will take place. So we can see the the inverted image. Okay, so we can see the inverted image of an objects. ಅಂದ್ರೆ ನಾವು ಬೇಸಿಕ್ ರಿಯಲಲ್ಲಿ ರೋಡ್ ಮೇಲೆ ನೀರು ಇದ್ದ ಟೈಪ್ ನೋಡಬಹುದು. ಸೊ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ನೀರು ಕಾಣಿಸ್ದಂಗೆ ಕಾಣ್ತಿರ್ತದೆ, ಅಲ್ಲಿ ಇರಂಗಿಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಏನು ಕರಿತೀವಿ, ಮಿರಾಜ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ದ ಬ್ರಿಲಿಯನ್ಸ್ ಆಫ್ ಡೈಮಂಡ್. ಬ್ರಿಲಿಯನ್ಸ್ ಆಫ್ ಡೈಮಂಡ್, ಬ್ರಿಲಿಯನ್ಸ್ ಆಫ್ ಡೈಮಂಡ್ ಅಂದ್ರೆ ಡೈಮಂಡ್ ಯಾವ ಟೈಪ್ ನ ಕಟ್ ಮಾಡಿರ್ತಾರೆ ಅಂದ್ರೆ when a light ray is passing inside a diamond, ಒಂದ್ಸಲ ಲೈಟ್ ರೇ ಡೈಮಂಡ್ ಒಳಗೆ ಪಾಸ್ ಆಯ್ತು ಅಂತಂದ್ರೆ so it will there are several reflection takes place inside the diamond. ಅಂದ್ರೆ ಒಂದ್ಸಲ ಲೈಟ್ ರೇ ಡೈಮಂಡ್ ಒಳಗೆ ಹೋಯ್ತು ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಒಳಗಡೆ ಏನಾಗ್ತದೆ, ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆಗ್ತದೆ. ಎಲ್ಲಿ ಆಗ್ತದೆ, ಡೈಮಂಡ್ ಒಳಗಡೆ. ಸೊ ಡೈಮಂಡ್ ಒಳಗಡೆ ಆಗಿ ನಮಗೆ ಯಾವ ಟೈಪ್ ಕಾಣಿಸ್ತದೆ, ಡೈಮಂಡ್ ಒಳಗಡೆ ಟೈಪ್ ಕಾಣಿಸ್ತದೆ. ಸೊ ಬ್ರಿಲಿಯನ್ಸ್ ಆಫ್ ಡೈಮಂಡ್. ಸೊ ಡೈಮಂಡ್ ಯಾವ ಟೈಪ್ ಕಾಣಿಸ್ತದೆ, ಹೊಳೆಯೋ ಟೈಪ್ ಕಾಣಿಸ್ತದೆ. ಇಟ್ ಇಸ್ ಡ್ಯೂ ಟು ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆಫ್ diamond. Next, total reflecting prisms. So total reflecting prisms. So in this case, a light ray is moving from rarer medium. Rarer medium is nothing but air is a rarer medium, and these are the prisms are the denser medium. When light ray is moving from rarer to denser medium, here denser medium to rarer medium, there is a total internal reflection will takes place. So total internal reflection will takes place. So we will get an inverted image. So total reflecting prisms are used for to get the inverted image because of the total internal reflection will takes place inside the prism. Next, optical fiber. So optical fiber is a material is made up of quartz or composite glass. So optical fiber is consists of two materials. First one is inner core is the two layers. First one is core, second one is cladding. First one, the inner layer we can say that core, the outer layer we can say that cladding. So what is by core? Core is behaves as a high refractive index. High refractive index. High refractive index is nothing but denser medium. High refractive index is nothing but denser medium. So cladding is behaves as a low refractive index. Low refractive index behaves as a rarer medium. Okay. Once light ray is incident to inside a optical fiber, so there will be a several reflection will be takes place in every angle is greater than critical angle. So first the light ray is passing from denser medium to rarer medium, means the core is behaves as a denser medium, the cladding is behaves as a rarer medium. The first light ray is incident to denser medium to rarer medium. In every angle is greater than critical angle. The light ray is passing from one point of a optical fiber to another point of a optical fiber. So where we are using optical fibers, so there are several uses are there. So where we are using optical fibers we are using in decorative lamp. Decorative lamp. Optical fibers are used in decorative lamp. So second one, the optical fibers are used in communication system. Optical fibers are used in communication. So next, the optical fibers are used to check the body organs. So these are the several examples of uses of optical fiber. See once again, total internal reflection we are completed, conditions of TIR, critical angle, the applications of TIR. So today's class up to this much. Okay, thank you.